solve some equations. You ready?
Why I love solving equations.
You are. I did that. It's my fault. I apologize. Yeah, it wasn't rhetorical. It was meant to be rhetorical. All right. So let's begin our lesson by solving this equation right here, a type of which you might have seen in the summer packet or something, right? So take a second to solve this equation. I don't know what happened to you. Yeah, good job. I think I got everyone but you. Oh my gosh. How's it going out there? The person who I've chosen to walk us through this is Emily. So whenever you're ready, you can tell me what to do. Or you can come up and do it, that's fine. See if you want to come up and do it here. She's going to show us how this goes. Here she comes.
When did that happen?
Make sure she's right. What's she going to do next? She divided by 20. We're going to give it a play-by-play here. Now she's expressing the right side as a power of 1/2. Strong move. She's equating powers. One move to kill this x equals 6, and she's done. She's put it in the can. It's done.
All right, Emily. Woo!
And the crowd went wild. Wild. You mind? Don't mind me. Don't mind me. Don't mind me. I like it. Do you like it? Did you check it? Does it work? Plug in 6 in the original equation. You can see that it works. Yeah, good job. Well done. Now, let me just add, because I know that you know how to do this. What's the technique here? She went out of her way to express both sides as powers of the same base. It was kind of the technique. She then equated them, and the rest is history. Okay. But what allows you to do this technique? I want to make sure we put a finer point on this. For example, if you have a squared equals b squared, it's not true that you can say, therefore, a equals b, right? In every situation, this is true, that this implies this? Sadly not, right? And yet you're saying right now that if you have 2 to the a equals 2 to the b, that therefore a equals b? For real? Always? I think you're right, but what makes the situation different here? I mean, why is it true that you can raise 2 to the a and 2 to the b and know that if you get the same result, that a and b must be the same? Antonio.
Because the base that's getting raised 3 times is the same.
Okay, but over here we've got, we're squaring both sides. We're taking them both to the second power.
No, but you see, no.
We're definitely doing the same operation on both sides here.
Yeah, but
we're applying the same function to both sides of the equation.
One is a random base, any number could be put in for a and b, but it's raised to the same power. The other one is a fixed number that's raised to any power. So any fixed number to any power that equals another fixed number, the same fixed number.
All right. Yeah, go ahead.
Because in the first one, a can be plus or minus b,
Okay. So I guess there's a function that's being applied to both sides here. We want to make sure we're clear. Here we're squaring both sides. Here here we took 2 to each side or something like that. If you're running it backwards, right? We squared both sides. Or here we took 2 to that side power, to that power. I don't know. Is there anything you want to say about those functions? What allows one function to have this property and yet another function to not have this property? What's special about the squaring function or the exponential function? I don't know. It comes to bear here too. Okay. Were you going to say the same thing for now? What are you
going to say this. You look at the one-to-one property.
Oh, it does. There's like a thing on this slide that gives it away. Okay. Yeah. The fact that an exponential function is one-to-one is the key thing, right? Is that if I square something, it's not true that I can recover the input, right? You know, I don't know what makes this fail. Why do we have a frowny face here? It's because it's not one-to-one, right? So we can't guarantee that the inputs. If we have a given output, we can't know what the input was. Whereas we can for an exponential function because it's one-to-one. And the same is true for log functions. We'll do some equations soon. And they talk like the log base b of something equals the log base b of something. And we'll know those two somethings had to be the same input, right? Given that the output is the same. Because log functions are also one-to-one. So yeah, the title of the slide gives it all away. Look at that. Okay. Let's give you a little bit more of a challenge. The first one, like I said, was one that you've seen on the summer packet. I think I tried to make it a little tricky, but this one's a little more challenging, I think. And so just kind of get you started, let me do the first difficult step for you, and then you do the next step. There you go. That's the kind of guy I am. There you go.
What if I want to figure it out by myself? I won't be.
I'm sorry to destroy that first step for you there. That was tricky. What are you going to do next? This is a little bit of a quantity. It is a quantity. Did anyone have a stroke of insight here? I'm willing to entertain a thought, but I'm also just willing to give you the next step too. Makes you go, very hard, right? What are we going to do? Well, I don't know. It's certainly true that e to the negative x is what? That's 1 over e to the x. I don't know. We'll write that. I'm not sure if that's hard or not, but what do you, any strokes of insight yet?
Wouldn't it be like ln 5e power base x plus 40%?
How would you solve an equation? How would you solve this equation? I just think you have solved this kind of equation before, right? Isn't this the kind of equation that we're looking at right now? I think you know how to solve this one. What would you do next here? Yeah. Yeah, for either one, they're the same equation. Yeah, I'd multiply by, in this case, e to the x. And let's be careful, what does that give here? E to the x squared minus 5 equals 4e to the x. Okay, and if you need to work out this example on the side over here, just to remind you what you would do next. Well, I don't know, what would you do next? If you were in this one? Yeah, you'd move it over to one side and have a 0 on the other. So let's do that. Let's make it. Okay. You would factor it. That's correct.
This is just quadratic.
Yeah, it's quadratic in e to the x, right? So how does that go? Instead of x and x, I have e to the x and e to the x, and I just need to figure out. This is a pretty easy factoring one, then. What do we get? So what does that mean? E to the x equals, sorry, plus 1. E to the x equals 5, and, or e to the x equals negative 1. Okay, so no, we're not done, of course. We would sometimes, if we were in the m problem, we would be done, but we're not done in our version of the problem. So we get here x equals, it's not a nice number, just say what it is though. It's, well, I just mean, I don't have a calculator, so what do we say it is? It's ln5, which is, okay, which is 1.6 or something, I guess. Okay, so I'll just leave that answer there. And then over here we get, what do we want to say there? ln, the natural log of negative 1, it's not a real number.
What's 7?
Oh, log, sorry, I don't know why I wrote 7. Was I thinking about 7? Where's 7 even in my life right now? I don't have a.
What is ln5? Maybe this is an old 7 is
so one way to think, so for those who are wondering, how do we realize this isn't going to work over here? One way to say it, you're right, is to say the natural log of negative 1 is undefined for us. The other way to say it, though, is before you even talk about logarithms, is just to be like e to the x equals negative 1 is nonsense, right? The exponential function doesn't output negative 1. Like, so you can either come at it from either direction, right? You can think there's no x value that would give me a negative value when I take e to that power, you know? You want to try another one? I know you do. Again, do you want me to do that first step for you here? No, to make it extra challenging, I have 2's and z's in the equation. You like that? Oh. Practice your penmanship. There you go. You could put a dash through your z. Yeah. The exponents are z and negative z, right?
I think I can choose one.
Why?
I believe.
Isn't it the exact same person?
Yes.
Always.
Yeah, well, I was thinking about it, and then you made me rush.
Wait, what's the problem out there? What's going on? No.
Isn't it 2 to the 1?
Yeah. But that's not going to be.
So that is 10 times 2 to the 1.
Right.
You can write that?
Yeah, what's the problem? What's the problem? Oh, you can't factor it? This doesn't sound like a problem to me.
X equals opposite b plus or x squared b squared.
Yeah, it doesn't work. Nothing that.
Complete the square or use the quadratic or
Let me just say my song. What if it wasn't even related to the problem? You're smiling now, but you won't be smiling.
Complete the square then.
Okay, so 2 is
Do as you like.
Oh, wait. 2 to the z is 1.
Guess who's not on?
Yeah. So I don't know.
Wait, those are Z's? I thought.
What's your method out there? People are doing what? What do you do? Quadratic formula, or you like the completing the square? What do you want to do? I'll do whatever the people cry for. Quadratic formula, okay. This is not bad to complete the square, though, right? And that's not a bad one for completing the square. But we'll do quadratic formula because I hear the outcry. Okay. So I don't know. I forget how this goes. Let's see. Negative. Here, I'll make one of you do it. There you go. That's a good idea. Reggie likes the quadratic formula. All right. So this is A is 1, I guess. B is -10, and C is -1. I'm ready for you, Reggie. Here we go. Yeah, the quadratic formula. You know it, right? So negative B. What do I write? You tell me. Well, no, just these are. This is A is 1, B is -10, and C is -1.
Oh, okay.
B squared, yeah, 100. So 100, like plus 4, okay. All right, in a minute, Reggie's going to simplify all that for me too. See how he does. Oh, oops, sorry, I got carried away. Root 104. Yeah, it's definitely 4 times 26.
Yeah.
Wait, how do you do that? Do what? Simplify radicals. I was never done that.
Well, 104, you look for perfect squares and just divide them out.
Like 10, right? I mean,
10 doesn't divide into 104. 10 doesn't divide into 104. 4 does.
You mean dividing?
Yeah.
Oh, so like.
So
It's
you
like
agree that
4 and then a total of 6.
104 is 4 times 26.
Yeah.
You agree? So that's the square root of 4.
Wait, and 4 goes to the outside and then 2.
Yeah.
Okay.
So what do we get here?
So then we get
5
5 plus
or minus
2
root
root 26.
26. So we got 2 root 26 divided by 2. Okay. But of course we're not done. Remember, that's not our answer. That's 2 raised to our answer. Okay. So
Now we have to do like
yeah. What next? Z is equal to
5 plus
log base 2
5
of that. Yeah. All right. We're feeling good about that answer. Wait. There's a look of concern on Stephanie's face. Help me. Root 26 is larger than 5? How do you know that? It's amazing.
5 squared is 25, so root 25.
I'm with you now. You're right. I think you're right that root 26 is a thing that is bigger than 5. Do you agree? Agree? People out there. So what are you saying we need to do?
5 times root 26 is not.
Only one answer here. Yeah, 5 minus root 26 can't be the argument of the log. True story. Okay. Yes, Reggie. Yeah. We've got what's the inverse of 2 to the z? Log base 2. Or you can think about rewriting it in logarithmic form, right? Log base this of this equals this, right? Let's do one that has a log appearing in it too. That looks like fun. What's your first move? Again, I'm looking for stroke of insight, a way to get started.
I would turn it into an exponential instead of log.
All right, so yeah, you might. So 80 says he'd like to turn it into exponential form. So what does he mean by that? And can we do it? What would I write? Yeah, t squared equals 100, right? Do you agree? So t is equal to plus or minus 10. Good. Wasn't so hard. Now, I'm sure none of you would do this, but one might, if they were, this is the right way to do it. I'm going to give you a big gold star for that. That's what I wanted to see. But in a moment of weakness, you might rewrite this way, and then write that, and then write this, and you'd be like, wait, I'm pretty sure negative 10 works too. What happened?
We talked about that.
Oh, we did talk about that. This is like, oh yeah. Yeah, when you go from here to here, what assumption did you make that's not well-founded? Well, you're assuming that t is positive. Well, that's not a fair assumption. So of course the only answer you get is a positive answer because you assumed it was positive. That's you assuming something. So do it this way. Just be careful. If you happen to know t is a positive number because someone tells you or something, you could do it this way, but just be careful. Be careful. Try another one. Similar kind of problem. What did you get? E squared is What'd you do? What'd you do next here? What'd you do next? What'd you do next? Rewrote it. As x to the 6 equals e to the 12, and then you did what? Yeah, so you took the 6th root, and you got e to the 2. I think I saw a lot of people with that answer. But you also need to say, right, you just took an even root. So just be careful, make sure you have both answers. I thought maybe we would learn from up here, you know, make sure you get the plus or minus e squared. For now, and then just do it.
So we can't say, okay, so if we subtract 12 on both sides, it would be negative ln to x to the 6 equals negative 12. And then
mean, if you did you say you're going to drop the power? Wait, which one?
So, never mind.
Just say it one more time.
So, ln, so if it's negative ln x to the 6 equals negative 4,
Sure.
then wouldn't it just, since it's negative ln, wouldn't it just be that negative 1 times ln, so it would be ln x to the negative 6?
Yeah, the ln x to the negative 6 equals negative 12.
Yeah.
Then you get the same thing. You'd get 1 over x to the 6 equals 1 over e to the 12, which is the same equation.
I see.
So that should work too. I think this is, I don't think you need to go there. But.
Yeah.
All right, hey guys, let's do one at a time right now, please. Then we're back together. Julie, thanks for your question. Thanks. Which step? You're good here and here, but just from the last step, or which one?
Yeah.
The last step. So can you say it again? What you did?
So
Shannon?
you want to make 6 be 1. So basically what you
B1?
do is you want to get rid of the power, the 6th power. So you put the whole thing to the power of 1 over 6.
So like the 1/6 power.
Because you multiply it, you're getting rid of the 6.
So she's saying that if you do x to the 6th and then to the 1/6, that equals x to the 1. Do you agree with her on that? I mean, the question is, how do you undo the 6th power? You take the 6th root. Now, this is actually a little bit of a lie, though. What is it really? Absolute value of x, right? Right, the absolute value of x equals e squared, so therefore, what must x be plus or minus e squared? Let's do one that has a log in it here.
Love this.
Wait, can't you just burn the wall?
I don't like you just, I got so confused by that. She's just like, it was so extra.
All right, we need another. We need another stroke of insight. You have a stroke of insight, Aiden? All right.
If you're adding two things to the same base, two logs to the same base, you can just multiply what you're taking the log of.
The arguments can be multiplied.
Yes.
This is like a property we learned yesterday. That's true. And over here, similar kind of story there. Yes. I mean, it's going to be. You're right. We may have introduced a new solution. That's the opposite problem of the last problem, right? The last part probably lost the solution. We may have just introduced a solution by doing what I just did there.
Well, yeah, but why can we just introduce a solution?
Well, yeah, we'll have to check them afterwards, right?
Oh, okay.
Yeah.
We're not just assuming that one.
No, we're not going to assume that everything is fine. And then what are we doing? We haven't used this property yet today, but we can use the one-to-one property, right? We have the log base e of something equals the log base e of something else. Well, then the two arguments must be the same argument since it's a one-to-one function. Using the one-to-one property? Burning the log. All right, what are we going to do now? Well, we're going to outsource this to our friend in Algebra 1, okay? Right? Maybe you don't have a friend in Algebra 1, but you get your friend in Algebra 2 to do it for you, okay? Help me out here.
X minus 2 X minus 2 plus 1. X minus 2 plus 1.
Oh, I was good. All right. Calm down. So what do we get? X equals a half or 2?
Yes.
Wonderful.
I'm not there yet.
So exciting. Oh wait. Do go back and check your work. Which one or ones can't you do? Michael, you're the one that's raising your rough stuff there. Go ahead. Tell us about it. Take them back to the original equation, if you will.
You can't plug it in one half because then the ln x minus 1
Yeah. I think this one will be a -2 maybe, huh? Yeah. Yeah, it makes both of these logs undefined in the original equation. No good. So just make sure you check them. It could be that both work. Could be that both don't work. Could be that one works and one doesn't work. Let's
One more.
Yes, please, one more.
all right.
Yes.
It's not any different really. It's just another one to try.
We got it.
It's another practice problem. Okay.
The more you practice, the better you'll get.
I hear that. Thank you, Jasmine. Yes. Just remember again, homework 2 from the book tonight is accompanied by a few problems from the challenge problems. So make sure you see those. Hopefully you're having a good time.
There are no answers. Oh, actually there is.
So only for -5.
He's already done. Jay Wu. Very good. What's this?
You have to condense it first, right? You can't just take away the base.
Right, because you would get something different. Yeah, use your proper logarithm rules along the way.
What do you just guess?
Did you guess all your answers? The danger in that is that if you guess one answer and you get it right, you might have to go. But what Connor needs to know that that's the only maybe there are 2 answers. Maybe there are 3 answers.
Just eye-opening. It's like invigorating.
What's the answer on this last one? Only 4. Have a great day. I'll see you tomorrow.